Now for the general method of converting degrees to radians. So this begins with a simple observation, which we've already seen. 180 degrees is half the circumference of a unit circle, so that's pi radians. So let's divide both sides of this equation by 180 degrees and see what we get. So anything divided by itself is 1. So we get 1 equals pi, you don't have to write radians, over 180 degrees. Okay, but how does this help us convert degrees to radians? Well, let's say we wanted to convert 30 degrees to some number of radians. Well, anything is itself times 1, right? So 30 degrees is 30 degrees times 1. And we just saw that the number 1 is equal to pi over 180 degrees. Okay? So 30 degrees times pi over 180 degrees. Well, 30 degrees is itself over 1. We have degrees upstairs and downstairs, so those cancel out. They're gone. 30, so that's 3 times 10. 180 is 18 times 10. The 10s cancel, which means these zeros at the end cancel. So this is 3 pi over 18. And 3 goes into itself once. It goes into 18 6 times. So 30 degrees is pi over 6 radians. And again, you don't need to write radians at the end. In summation, how do we convert from degrees to radians? We multiply by pi over 180 degrees. It's that simple. Now, if you don't get that, I'm not saying that you're a poop head, but I am saying your cranium is filled with feces. Okay, let's do some examples of converting from degrees to radians. As we know, all we have to do is multiply by pi over 180. So 60 degrees, let's multiply by pi over 180. 60 is 60 over 1. Okay, so 60 is 6 times 10, 180 is 18 times 10, so the zeros will cancel out because those are really 10s that are being multiplied. So 6 goes into itself once, goes into 18 3 times. So upstairs we have 1 times pi, downstairs we have 1 times 3, everything else canceled out. So 60 degrees is pi over 3 radians. Okay. What about 120 degrees? Well, multiply by pi over 180. Okay. So again, the zeros at the end are really just factors of 10, so we can cancel those out. Can we think of any common factors of 12 and 18? Yeah, 6. So 6 goes into 12 twice, goes into 18 3 times. So upstairs we have 2 times pi, downstairs we have 1 times 3, and that's it. 120 degrees is 2 pi over 3 radians. Couldn't be easier. Note as well that 120 degrees is twice 60 degrees. So if you knew that 60 degrees was pi over 3, 2 times that has to be 2 pi over 3. Okay, 150 degrees, same deal, pi over 180. Zeros cancel. Anything that goes into 15 or 18? Maybe our favorite magic number, 3. So 3 goes in upstairs 5 times, goes into 18 6 times. So we end up with 5 times pi over 6. 5 pi over 6 radians. All right, on to 300 degrees. Same thing, pi over 180. Same thing, the trailing zeros, we can just cancel them out. Now we have 30 upstairs and 18 downstairs. Remember, this is really 30 over 1. Any common factors here? What about 6? So 6 goes into 30 5 times, goes into 18 3 times. So upstairs we have 5 times pi, downstairs 1 times 3. So this is 5 pi over 3 radians. Now that makes sense, right? Pi over 3 was 60 degrees. So 5 times that is the same as 5 times 60 degrees, which is 300 degrees. Okay, on to 240. 240 times pi over 180. That's all we do every time. Multiply by pi radians over 180 degrees. So 240 is 240 over 1. The zeros cancel. Common factor, well, 6 again. So 6 goes into 24 how many times? 1, 2, 3, 4. Goes into 18 3 times. So upstairs, 4 times pi. Downstairs, 1 times 3. This is 4 pi over 3. And that makes sense too, because remember, pi over 3 was 60 degrees. So 4 pi over 3 is 4 times 60 degrees is 240 degrees. Finally, 225 degrees. Well, I'm going to cheat a little bit with this one because this one's a little tricky. So let's observe that 225 degrees is the same as 5 times 45 degrees. If you don't believe me, do 5 times 45 in your calculator or on paper, whatever you want to do, use an abacus. It'll come out to 225 degrees. If you remember, 90 degrees was pi over 2. We saw that earlier. 45 degrees was half of that, so pi over 4. So this is 5 times pi over 4 radians, which ends up being 5 pi over 4. That's it. So we've converted all of these from degrees to radians. Now you might object about that last one a little bit. 225 degrees going to radians. Remember, we used the trick. We said that this is 5 times 45 degrees. Without that trick, maybe we couldn't have done it. Well, you actually can. And all you need to do is do the same thing. Multiply by pi over 180 degrees. So 225 degrees times pi over 180 degrees. And 225 degrees, that's 225 over 1. Okay, do we need to use a calculator here to do this reduction? No. You only need to use your brain. Okay, this ends in a 5. This ends in a 0. So a common factor is 5. Right? If things end in a 5 or a 0, they're divisible by 5. So let's do 225 degrees divided by 5. I'll show you a little trick for how to do that. So 225 degrees divided by 5. Well, dividing is multiplying by the flippy dippy, or the reciprocal. So that's 225 degrees times 1/5. And 1/5 is the same as 2 over 10. Right? If we reduced 2 over 10, 2 goes into 2 once, goes into 10 5 times. So multiplying by 1/5 is the same as multiplying by 2 over 10. Okay. So in essence, to divide by 5, You multiply by 2 and then divide by 10. That's a little trick. So 225 times 2. Well, 2 times 200 gives us 400. 2 times the 25 gives us 50. So this is 450 over 10. Comes out to be 45 degrees. Okay. So a nice little trick. To divide by 5, you just multiply by 2 and then divide by 10. And when you do that, you see that 5 goes in here 45 times. And how many times does it go into 180? Well, multiply by 2, divide by 10. So 180 times 2 is 360. Divide by 10, that drops to 0, takes us to 36. And then the degrees cancel. So this is 45 pi over 36. Are we done? I think not. It's not the answer we had before. So there's a little bit more reduction we can do here, because 9 goes into both of these. So 9 goes into 45 5 times, goes into 36 4 times. So we end up with 5 pi over 4 radians, just as we got last time. Hooray!